Oh, sorry about that, my iPad dropped me. Okay, so the sine inverse of 0.55 equals the measure of angle B. So to find the measure of angle B, we go sine inverse 0.55. So the measure of angle B is approximately 33.4 degrees. Again, this is just us practicing. This A, B, and C aren't all angles in the same triangle. Okay, so if the cosine of C is 0.87, then the cosine inverse of 0.87, and the only reason I put parentheses around this is so you know you're taking the cosine of this whole thing. Hey, you don't really need them, and that's how your calculator types them in, would give you the measure of angle C. Angle C, so the cosine inverse of 0.87. So the measure of angle C is approximately 29.5 degrees. Okay, so what does it mean to solve a triangle? Well, when you solve an equation, you find out what number the variable has to be. Hey, when you solve a triangle, you find the value of all the missing pieces. You find the value of all the missing pieces. That's side lengths, angle measures, any of that. Okay, so to get us a little used to some notation, okay, in a triangle, normally we have the right angle at C, not always, and the vertices A, B. We'll have this be A up here, sorry, typo, I want to go A, B, C clockwise. Okay, A, B, C. Okay, so here's angle A. So side A is normally across from angle A. So this is lowercase a. This is lowercase b. This is lowercase c. And I also want to, a lot of times for angle measures, for this angle in here, we would either refer to it as the measure of angle A, or we use Greek letters. Greek letters are used a lot for angles. Okay, so if you see one, there's nothing wrong with using a Greek letter. Basically, it's just we ran out of regular letters of the alphabet, so then we go into other letters of the alphabet. One most commonly used is this one. It's a circle with a line through it. It's the Greek letter theta. Okay, so it's a circle with a line through it. It's the Greek letter theta. That one's used a lot for angles. Another one is the Greek letter alpha, which looks kind of like a little sideways fish. It's the Greek letter alpha. That's the first letter of the alphabet, so it tends, the Greek alphabet, so it tends to be used for A. We use angle A, alpha. Okay. We also have another one that's used a lot is beta. It kind of looks like a B, except it has a tail. It's kind of not straight up, it's more curvy. This is beta. Okay. And then we also have gamma, which my gamma looks a little different from. So there's the gamma symbol. Go ahead and Google, you have a computer right now, go ahead and Google gamma, or Google the Greek letters of the alphabet so you can kind of see what they look like in type. Okay, when you type them, it's a little different than how that looks like when you write them. Okay, so theta, alpha, beta, gamma, these are all used for angles. So a lot of times in this angle here, they'd have a theta sign here instead. Measure of angle B. Okay, it's just another way that we use to denote our angles. Okay, so other textbooks use them a lot more often. This textbook doesn't even mention them, but I want you to be aware of that. Con uses these letters a lot, theta, alpha, beta, gamma, and so do other textbooks, and you will see them on things like ACT, state testing, that type of stuff. So I wanted you to be familiar. It's not anything crazy, it's just another letter of the alphabet, just not our alphabet, it's the Greek one, okay, that we tend to use for angle measures. Okay, so when I'm asked to solve a triangle, what it's wanting me to find is the value of all the missing parts, meaning write down the angle degrees of all the angles and the segment length of all the sides. Okay, so we need to find all those missing pieces. So here in this example, solve the right triangle, round the decimal answers to the nearest tenth. Okay, it doesn't tell you how to solve them, so really it's kind of up to you. Oh, this would be A here. Okay, if I notice, I know almost all the sides. I know two sides, I'm missing a third. Since I know two sides, I can use the Pythagorean theorem here. So I'm going to do that first. A squared plus B squared equals C squared. Okay, here's my a squared plus b squared. Here's my hypotenuse here, so this would be my c. A is across from A, O, C. I hate that. So this is B. These points are in the wrong spot. Okay, so let's get rid of A and B and C. But this one is my hypotenuse. So we're missing this side here from A to B. So we can go ahead and let that be our x. We're still trying to find A to B. So we know x squared plus 24 squared equals 25 squared. Okay, so I would need to, let's go 25 squared is 625. 24 squared is 576. Okay, I'm going to subtract the 576 from both sides. $49. X squared equals 49. So then x would equal the square root of 49, which is 7. Actually, Pythagorean triple. So we know this side is 7. So I'm going to go ahead and label that in the picture. We know that side's now 7. Okay, so we found all the sides. So I would label, okay, we know side A to B is 7. Side A to B. Don't use an x because we added the x in there. It wasn't in the problem originally. Okay, so we want to solve the triangle. We want to find all the missing pieces. We don't know any of the angles. So this is where our inverse comes up. You can use any angle you want. I'm going to look at, I think, angle C. And I'm going to use the sides that I know. The sides I know are this side, which is the adjacent side, and this side, which was the hypotenuse. I always try to use the sides they give me as opposed to the one I solved, because what if I goofed when solving this one? And then the next one would be goofed too. Okay, so this is adjacent hypotenuse. So I know that the adjacent hypotenuse is, let's write down SOHCAHTOA. I write that at the top of all my papers. So I know, oh, sorry, SOHCAHTOA. Cosine is adjacent hypotenuse. So I know that the cosine of C equals the adjacent side over the hypotenuse. Well, I know both of those missing pieces. I don't know C. So since the cosine of C equals 24 over 25, then the cosine inverse of 24 over 25 is going to give me C, the measure of angle C. So I need to take cosine inverse, 24 over 25. It's all there inside the parentheses. We get 16.3. So I know the measure of angle C, and the directions tell me round decimal answers to the nearest tenth. Measure of angle C is approximately 16.3 degrees. So we found the measure of angle C. Now we just need the measure of angle A. Well, we can find that without doing any approximately. Again, rounding. I know these two are complementary, so if I just take 90 minus this, the 16.3, we get 73.7. So there. We found all the missing pieces. We were missing A to B, we were missing angle C, and we were missing angle A. Okay. So we found all those missing pieces. Oh, we can also measure angle B, but it's given, it's a 90. It has that little 90 in there, so there's really no need to write that one down. Okay. Here's another one, extra example 4. Solve the right triangle, round decimal answers to the nearest tenth. Okay, so they give me angle X here, so we can find angle Y. So we'll write that first. The measure of angle Y equals, we would need to take 90 minus the 41. We get 49 degrees. So we found the measure of angle Y is 49 degrees, so this angle is 49 degrees. Now we just need to find the two missing sides. So again, pick an angle. I'm going to pick the angle they gave me here, that's 41. And pick a side. Which one do we want to find, X or Y first? X, alphabetically. X is, of course, opposite. This one is the hypotenuse. So opposite hypotenuse is sine opposite hypotenuse. So the sine of 41 degrees equals the opposite side X over the hypotenuse, 18.4. Okay. Over 1. Let's means extremes it, so we'd have 18.4 times the sine of 41 equals X. So I take 18.4 times the sine of 41. We get 12.1. X is approximately 12.1. And again, this is units. because it's that length. So this one is approximately 12.1. Put it in the picture. Okay. Now at this point, since I know two sides, our options are either use Pythagorean theorem or use trig again. I think I'm going to stick with trig. I'm going to find this is the adjacent to 41, so let's use cosine of 41. Adjacent over hypotenuse. Again, means extremes, 18.4 times the cosine of 41 equals y. So 18.4 times the cosine of 41, 13.9. So y is approximately 13.9. Okay, so we found all the missing pieces. We found the measure of angle y. Okay, we found x, which we could write as that's the distance from y to z, is approximately 12.1. And then we found y, which is the distance from x to z, is approximately 13.9. So we found all of our missing pieces. Measure of angle y is right up there. So we found it all. This triangle is solved. Okay, one more application type problem. Your school is building a raked stage. How a rake stage works is the front of the stage to the back of the stage, it's a ramp. So as you're looking to the back of the stage, it raises up. Basically what it allows is the people standing in the back of the stage can be seen over the people to the front of the stage. Okay, the stage will be 30 feet long from front to back. So we know from here to there, that would be the hypotenuse is 30 feet with a total rise of 2 feet. You want the rake, the angle of elevation, to be 5 degrees or less for safety. Is the rake stage within your desired range? Okay, so drawing this again that we can write on it. Here's my 90-degree angle. This has to be 30 feet. This here is 2 feet. We want this angle here, we want this angle to be 5 degrees or less. So this is really the angle we want to find. So let's label A, B, C. We want to make sure the measure of angle A has to be less than, we'll write it in words, less than or equal to 5. So let's find the measure of angle A. Well, we know if this is my measure of angle A here. This is the opposite side. This is the hypotenuse. So that would be sine, opposite hypotenuse. So the sine of angle A, opposite 2, over hypotenuse 30. So if the sine of angle A equals 2 over 30, then I would go the sine inverse of 2 over 30 equals the measure of angle A. So sine inverse of 2 over 30 gets me 3.8. The measure of angle A is approximately 3.8 degrees. Is the rake stage within your desired range? Yes, since it is less than 5 degrees. We're good, because it's only 3.8 degrees. So my rake stage is safe. Okay, so there's the end of 9-6. If you have any questions, please come see me, and good luck on your practice.